Today we will try to cover linear interpolation for the basic theory. Okay, linear interpolation is this. You connect 2 points with a line. And okay, sir, for you just come in. You already with the group? Not yet? Are you with the group?
Yes.
I reserve 5 seats.
He's got to have 5 computers reserved for his class.
Yeah, okay, for my class. From 11 to 12:30. Just that. Okay, for linear interpolation we have, you connect 2 dots with a line, straight line, okay? And the question is, how do you predict y value if you know the x value that is in between those 2 points? So first step we do slope. We connect 2 dots with a line and you have y minus y0 divided by x minus x0 equal to y1 minus y0 divided by x1 minus x0. That is linear equation, right? Okay, so you can do this. We arrange it, we can have it in this form or that form. That's a linear interpolation. So this means if we know x0, y0, x1, y1, we can predict x and y. That is, and if we know x value, we can predict y value. Let's, I have no picture. That's it. That is for linear interpolation. You get the point? So we need x0, y0, x1, y1, and we need one more for the value of x. Then we can predict y, or if we already have y, we can predict x. Question? No question. Alright? So, for linear interpolation, if we have many points, so for vector x, we have 1 to n. Vector y, we have another 1 to n. So this means if I ask for the value of y at any x t, I can calculate that y value, correct?
What is the value?
So in the notebook I use value. You see. So I have many points, many x and many y. So if I tell you one x value, you will be able to give me y value. But first step we need to know, so where is the interval that x is in, right? If we have many points, we need to know. So you have x and y. So you have this point, this point, this point, this point, this point. Of course, for linear interpolation, we connect each dot with a line, like straight line. Oh, straight line. So we connect with a straight line, right? Just straight line, no curve or anything. So if I tell you, hey, if my x equal to, so if my x equal to this point, where's my y? So first step is to find which interval that x value stay. So I know that I have this as the known x value. So the unknown x or the unknown y, the interval, so this x is in that interval, right? So we will use, so once we know which interval that x is in, okay, it's 11:05, you're fine. So then we know that we have to use that value and that value for the linear interpolation, correct? So the first step is to find the interval that x stay. Alright. So once you know which interval that x is inside, then you use adjacent point, adjacent x0, y0, y1, x1 to do linear interpolation. Very easy, right? So how do I find the interval that x stay? Okay, let's open IPython notebook. Okay, and run cell by cell. The first cell is import all the library. Oh, is it going to work? It should. So the second one is a markdown cell. Do you know how to create markdown cell? Escape M, right? There's something wrong with this. Oh, it's done. Okay. So I create X is linear space from 1 to 100 with 10 points. Y is log base E of X. Okay. Then I have this as a X and Y value. Next, I plot them. Okay. I put it in a table form by use data frame. Right? You don't worry much about the data frame. It's just make it look cute. Just that. I plot it. Okay, now, based on the given data, use the interpolation to find x at y equal to 17.68. So 17.68. When I go back, 17.68. So this means it's not in between 0 and 1, right? It will be between 0.1 and 2. By looking at it, I can tell. But how do I tell without just looking at it? Jay, you can sit over there in the back. Okay? That computer doesn't quite work. So how do I know without just looking at it? This time I look at it and I can tell, hey, that is the interval between 1 and 2. So manual method, find the interval that cover the point of interest. So I use argmin dot argument minimum argument. So my value equal to 22. Okay. IDX is index of x is numpy dot absolute vector x or numpy array x minus 22. So I use, okay, let me run it. So I run cell number 5 already, and you should run it too. Did you? Run it too. And you tell me what is this one. numpy.abs.x x minus wow. What is that? Without running, you can tell, but may not be correct. So I run it. So this tell me I use x and all the x minus 22. Y is 22. It should be, maybe I make it twice. It should be 17.68. Okay. So let's check this to 17.68. Which one is the IPython 5? It is in the presentation.
0 to 6.
08. We have 8. So 17.68. So if I do that, I try to find the shortest distance. You see my point? Your computer doesn't work or what?
It doesn't.
It doesn't work? But it is on. What's the problem? That one doesn't work either. Do you want to ask me to ask one of them to leave or what? But just with Josh for now. Okay. But you can use your laptop, but not on the test day, okay? On the test day, you make sure that you can do it. If you cannot do it, you get 0. Alright, absolute value of x minus y is to calculate the distance of x from each point, right? And we find the minimum distance. So, minimum distance is 5.32. That is minimum distance. Agree? No problem, right? Except if you come late, you may have problem, of course. Daniel, you got what I say? Minimum distance, what is that about? Minimum distance. Absolute value of x minus y. You got it? So this line calculates the distance between the point x that we want to find and the vector x. Vector x is this one. 1, 12, 23, 34, 45. So all of that minus 22.
So, first question.
Next time come on time, okay? What is your problem, mister?
Sorry.
Is there any university excuse that make you come like this very often? It is difficult for me to explain it again.
Oh, I just want to ask one question.
Yes, of course.
Why do you get the value of 22 at the minimum argument when you cannot see? I think the value should be 1, the minimum argument.
Okay. Let me repeat myself one more time. We have several points. Okay, the point is like that. And if I want to know, hey, if x is at 17.68, what is the interval that covers that unknown x, or that covers that x of interest? Okay, so I calculate the distance. There are several methods of doing this, okay? First, one of the methods is calculate the distance between the blue point and your x. Okay, use absolute value of vector x minus 22 or minus 17.68 every one. So basically I do 1 minus 17 point something, 12 minus 17 point something, 23 minus 17 point something, 34 minus that, 45 minus 17 point something, and I get the value. When I use the argmin will tell me the index of the minimum distance value. Okay, so tell me what is the value of idx. What is the value of this expression over here? Daniel, can you run the code? Or you don't even open the... Open the IPython notebook, sir. Okay? Open the IPython notebook. Run just that line and tell me what is that. I get 2. When I run just that line, absolute value of x minus 22 or minus 17.68 dot argmin, I get 2. Is that correct? It's correct because the minimum dot argmin doesn't give you the minimum value, but it gives you the index that has the minimum value. Look at this one. If you don't have dot argmin, what you get is 0 at point 0, at point 1, and at point 2. So the minimum value is at point 2, which is 5.32. Okay, that is the point where we have minimum value. Okay, then I do this. I say if x at that index greater than value or value of x that we want to find, the y value, index equal to index minus 1. So these two lines is to do what? Daniel?
I want to find the code.
Nanchen Lee.
So we try to step one step back in the list to get X.
Do I always step one step back? No, I don't. Only sometimes. Only for the case of the known X at argmin is greater than
Yeah.
val, or the X value that we try to find the interpolation. So basically, I want to find the left
Yeah.
of the interval. So the known point, if my known point look like this, okay, argmin will be this, right? Argmin will be that one. Is that one is on the left of the interval? I don't know. What if my X is over here? If my X is over there, the closest point will be the same point, right? And I don't know if the available point that is closest is that on the left or on the right. I never know. How do I know that? I use that if statement, right? So if this value minus x val greater than x val something. So if you look at the code, so x at minimum index, if it is greater, that means it is on the right side, right? I don't want the point on the right, I want the point on the left. So I minus 1. But if it is already be point on the left, I don't minus 1. Not clear enough. Clear enough? Jerlin?
Yeah.
Okay, let's move on. Jerlin, have you finished homework?
Not yet.
Not yet? Amir?
No.
Okay, let's talk a little bit after class. Okay, so basically these 4 lines, 3-4 lines give me the left index. Okay? And then to find the same thing, I can use numpy.search sorted. .search sorted is to give the location. Okay? Like if the value is inserted before this index, the value the order will preserve. So basically if you do search sorted vector x that have several points inside and the value val. So this will give me the interval, but it will give me the right point that cover the axis of interest. So if I minus 1 over here, it becomes the left point. For more information, press what? Daniel?
Shift out.
Do it, please. Click over there, press Shift tab.
Okay.
Read it for me, sir.
He said, hold up. From the indices into a sorted array.
You didn't get the same thing I got? I just get one line. Find this is where elements should be inserted to maintain order. I just get that. Do you get the same thing? So this kind of technique is to be used during the exam. It's quicker than Google. Okay. So I get the point on the left. Alright. Now I know the point on the left. The next step is to do interpolation. Interpolation, come on, turn off the cell phone or silence it. Okay. Laundry, is this laundry? No, it's not laundry. You have your group? Okay. So you do linear interpolation. Linear interpolation, just use the formula. So the formula is this one, right? Y0 is y at index. Y1 is y at index plus 1. Y0 is y at index. X over there is val. Right? I just put the value on the formula. That's why it's this. And then I'm done. Okay? And it gives me the interpolation value for the y value. Okay, now I plot it to show you that it is actually on, you see, the point of interest is on the straight line connection between 2 points. Done. That's linear interpolation. You can. This is manual method. I consider it as manual method, even though you use NumPy array and something else, because it doesn't automatically calculate. It doesn't automatically do the linear interpolation. Or you can use NumPy.interp val, comma s, comma y. Val can be NumPy array. Many point of interest. If you do that, it gives you the same thing. If you do many point of interest like that, then I get many answers. Run it. See if your code run or not. Run until that line. That's input number 12. Come on. Does it work? Just click shift enter. Jared, you done?
Yes.
Okay. Question for you guys. Do I use matplotlib to do the plotting this time? I mean, they use matplotlib? Matplotlib.pyplot. I used it to some extent, but I also use dataframe.plot.scatter. Okay, I plot it directly, but from the data frame. That's used like Panda library. You see, df come from pandas, right? So if you have Panda library, you can plot it like that too. So this means we do linear integration of many points. Okay. Linear extrapolation. Okay. The equation. Who want to answer my question? George, furthermore?
Last question.
I haven't asked yet. Okay. So for linear extrapolation, do we have the same equation as linear interpolation? Not the same? Are you kidding me? Could you please check it again? Is it not the same? It is identical. Exactly the same. Okay? So whatever technique you use for interpolation, you can use for extrapolation. But this time, maybe there's a little bit of difficulty. So you have to find what point that you're going to use for extrapolation. If you want to do extrapolation, the only time that you want to do extrapolation is the point is outside the known domain. So if you don't have, you know the value of y from x equal to 0 to 2, but you want to extrapolate to x equal to 3, you have to do extrapolation. And if you do linear extrapolation, you use last 2 points that is closest to the point of interest, right? So I use search sorted minus 1 as before. I use the formula. Okay, I plot it. It is fine. It gives me the red dot. Run the cell, please. Do you get the same thing, or it doesn't work? Okay. Now about plotting. You should be able to do the plotting, okay, by Google or read Stack Overflow during the test time. No, it's not that difficult. For the exam, you can do what you did for the cone and parabola. Take a look at this. I do RO. What is that RO? Red circle, right? Linear extrapolation, that's the label. So this kind of thing you knew, right? Do you? Okay. What's the problem with try to do linear extrapolation with log function? The answer is wrong. It's very wrong. So if the point is far away, it will be worse. Why do we want to do something like that? Why? When do you want to do extrapolation? Conceptually. We know that it is wrong, but why do we want to do that?
Because we want to get values that are not covered within our data.
It is better than random guess. right? Okay. So sometimes even though it's wrong, it's still better than nothing. Really? If you know, assume that you don't know that the function is log function. You don't know if it is log function, and you have just this line. You have just this dot. Okay, dot 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 dot. Just those dots. So if I ask you, hey, for x equal to 22, what should be the value? If we don't know the function, we can have several kind of extrapolation. You can say, okay, that point or that point. How do you know? If you don't know the function, just use linear interpolation. But if you can do nonlinear curve fitting, and you, hey, fit with the log function, assume that we don't know, so we cannot do any of that, right? The best thing we can do at most maybe linear extrapolation. Cubic spline, may not work either, but we'll talk about that. So here's the x value. Okay, it n at 2. Information of x, information of y. Okay, I can. So this method is what? Manual method, right? Is it manual? So I have y. What is that y? Is it vector or scalar? Really? Did you check? Check it. Oh, it is vector. So I can. Did I do vector? Okay, y is a vector. That's why we can do this. Okay. So we have one point. What about interpolate dot interpol 1D kind linear fill value equal to extrapolate? What is that about? It do the same thing. It do the extrapolation, but it's kind of automatic. Okay. Where do I get this from? Naturally. How do I get? What do I have to import to do this? Go back to the top and answer the question. Yes. What's your answer?
From SciPy import.
And importable.
Okay. It is from SciPy, right? So y value of SciPy is linear interpolation of y. So look at this carefully. Lin inter, what is that? Is that vector value or scalar or something? It is an object. It's like object. It's like a function that is defined like that. So the output is extrapolation value. So once you declare to be that class or that object, then you have to run it. Okay. Do this line. Doesn't do anything yet. Doesn't do anything yet. You have to run it.
Or if we add brackets for like
You try. That's why we have computer. Try it now. Try it now. Try it now and tell me. I don't like the question like what if that, what if this happened when you have your computer on in front of yourself. Just run it and tell me what happened. What do you get? Do you hear the question? The question is, what if we don't write two steps? We write just that, and at the end we put parentheses. Wow, is that going to work? That is Daniel's question, right? Does it work? You don't know. Naturally, can we try if it works? His question is, he don't want to write line 18. He want to write just that thing and put parentheses at the back. It worked correctly. Why should we not do that?
It's long.
Okay. You want to do this one. Simple. Okay. Beautiful is better than ugly. Explicit is better than implicit. Okay. Simple is better than complex. complex is still better than complicated. What you did? It's long. Okay. It doesn't look cute. Just that. So we don't use it. Readable count. Readability count. Okay. Import Zen of Python. We don't do any of. You can do it. It's okay. But if it is too long, it's not good. So we have the way to do extrapolation, right? Actually, interpolate function from SciPy can do interpolation too. Alright, what about 2D data? What do we do? 2D data. So I have temperature and pressure. Temperature from 50 to 100. Pressure from 100 to 5000 psi. Okay. And I do mesh grid. And that's the point. So I have 100, 100, 100. So 100 to 5000. Right now we have 2D data. Let's assume that we have viscosity data into 2D data. So viscosity is assume that it is a function of temperature and pressure defined like that. But you don't know actual function, okay? If you know actual function, you don't need to know interpolation. Okay. So what do we do? This time, viscosity is a function of both temperature and pressure. In the lecture, what do we do for 2D interpolation? So you can do interpolate.interp2d, or you can do what I did. So viscosity, I plot the viscosity. Look at output number 27. You see that color? Sure. Did you run your code? Shift enter, shift enter, shift enter until you get that line. You see the color. So x-axis is temperature, y-axis is pressure. Okay? And your viscosity is a function of both temperature and pressure. And we have a certain number of known points, but what if we want to know viscosity at the temperature and pressure that is not given? We do 2D interpolation. Okay. To do 2D interpolation, okay, here's the 3D plot. Do you know how to do 3D plot before the test? Okay, you should. Alright, this is 3D plot. Another view of that 3D plot. Okay. So I want to show you in a table format. I have T1, T2, T3. So this is different column. And I have different row, P1, P2 until last P. And inside I have viscosity. Okay. So to do 2D interpolation, okay, now I generate my Panda data frame. Okay, Panda data frame has zero pressure, zero temperature, and inside is viscosity data. If you worry how to do that, read this, okay, do that. But it's difficult to just teach you quickly like this. Okay. What I did is, I load the data from the data frame, for the data frame from file to data frame. So, df.to something, something, something. So, first I create the data. Once I create the data, I load the data. Panda.readcsv, that is to load the data.
Professor, can you put the labels on the table using data frame?
Yes, I can. Maybe I cannot right now, but
we can.
Last month I can. So for now, we don't cover Panda. I just show you what I did. Just that. If you want to know more about Panda, how we do all that, go to the code by yourself. We don't tell you on that either. But just for you to aware of, there's a better way of doing it. Okay. So use Panda data frame. Let's keep working with pandas. Okay. Alright, we want to find viscosity at temperature equal to 70 Fahrenheit and pressure equal to 3000 psi from data file. Okay. I think I have some picture to show you how I do it. Okay. So when you want to do 2D interpolation, basically you see this temperature T, okay, T target value is at 70, right? That's your target temperature. And you have target pressure is at 3000. What about the adjacent point? You have 4 points that cover the target point, right? There's a 4 point around the target point. How do you find it? I use search. You have to search twice. So you can use search sorted -1 twice. So you search on temperature axis first, and then you search on pressure axis. You can do that, right? You do search sort, or if you use argmin and if statement is fine too. Once you do all that, there will be 4 values cover your point of interest. Okay. What I did is 1 point of 109 something or 93. So that 4 value in the corner, that is from lookup table, the known value. So we have that value, that one in the top and that one at the bottom, given. It is given. 2D interpolation, 2D linear interpolation means there are 2 ways of doing it. Okay, one of the way is you find viscosity at X target for pressure equal to 2000 to 2550. Okay, so you interpolate between that point and that point to get the value at the temperature of interest, but it is not at the pressure of interest yet. It is the upper bound. We want to know at 3000, but we have the value of 2550. So first step, you ask yourself, hey, at 2550, even though it's not the target, it's a lower bound, right? It's a lower limit. At that point, what is linear interpolation value at the temperature of interest, which is 20? So I do linear interpolation between that and that to get that value. Okay, that gives me the lower bound at 2550. Then I do the same thing to get viscosity at the temperature of interest, but at the pressure of upper bound. Upper bound pressure, which is given, is 3040. I know that value. I do linear interpolation between that value 79.5 and 81.2 to get viscosity at 70 but at upper bound pressure. So right now we match temperature, right? We match just temperature. Next step is you use that value and that value, do linear interpolation again to get X at the target. Okay? Get my point? So you have lower bound pressure, upper bound pressure, and you have 2 points of temperature. You have T low and T high, but you don't have value at T target. So you do interpolation between that value and that value to get temperature at the target, which is, it is at temperature target, but it is at lower bound of the pressure. Then you get viscosity at the target, but at the upper bound of the pressure, by use upper bound pressure value. Okay. And then you use T target low pressure and T target high pressure to find viscosity at pressure target and temperature target. Just that. Okay. So this requires you to do 3 linear interpolation. So how did I do all that? I did it. So first I do numpy search sorted minus 1, numpy sorted minus 1, so I get left index or lower index for T and P, right? Once I get lower index for T and P, I do after I find the index, so T is at 2, so 2 and 3, 5 and 6, I get the pressure, I get the viscosity at 4 corners. Once I get the pressure at 4 corners, I do linear interpolation twice. So first time, I get 103, which is the top one. Second time, I get 90.977, which is the lower bound. Then I do linear interpolation between those two again. I get temperature at the interest point. Done. Okay, let's move on.
You have question? No question.